All right, guys, as we were saying, so I was asking about integers, and I don't know if anybody had attempt to answer what they understand about integer. What about you, Miss Green? What do you know about integers?
Not much, sir.
Not much. Mr. Ojeno, you know anything about integers? Are you hearing me, Mr. Ojeno? Can you hear me? All right, I'm not getting a response.
Yes, sir. I think integers are whole numbers that are not fractions.
Okay, all right. Miss Travia, what do you think about integers? What are integers?
I really don't know.
Okay. Miss Scott, do you have anything you can tell us about integer?
No, sir.
Okay. All right. So it means that we don't know much about numbers. All right, you will learn, no problem. All right, Miss Waysome, you want to
Yes, sir.
tell us something about integer, Miss Waysome?
Sir, I'm looking at it. Integers can either be positive or negative numbers.
Very good. So they are positive and negative numbers, including 0, all right? Now, the next number that we have in the number system is rational numbers. What do you know about rational numbers? Anybody? Ms. Scott, you know anything about rational numbers?
No, sir.
Ms. Green? Ms. Green, you know anything about rational numbers? Ms. Cummings?
No, sir. No, sir, I'm not sure.
Not sure. All right. All right, we'll get back to them. Don't worry. Irrational numbers. Now, well, the common sense to irrational number is that if it is not rational, then it is irrational. And we'll look at those. And then now, real number would be the set that consists of all the previous ones. All right. So I'm going to go through them again and give some clarity as to what these numbers are. And hopefully by the end of this class, you should understand the number system clearer, all right? Now, I had mentioned complex number before, but for the purpose of CSEC maths, you won't be doing anything with complex numbers at all. But just to mention that there is such a number that we call complex number, and these numbers are used in computers, right? And we will just appreciate that there are numbers that are complex that we don't want to concern ourselves about at CSEC level. If you decide to take math to a higher level though, like at a more advanced level, you will learn about complex numbers. All right, so this is a relationship with all the numbers. I know that everybody is new and may not be familiar with this symbol, but Out of curiosity, anybody know what this symbol is?
Sir, I know what it represents.
All right. Tell us, Ms. Wesa.
That symbol is a subset of.
Right. So that symbol means is a subset of. And so when you see the symbol, you should read it in that way. So symbols in mathematics are like words in dictionary, right? Every word has a meaning in the dictionary. Every symbol has a meaning in mathematics, and not just a meaning, it has a specific meaning. And so it is important that you know the specific meaning. So you will get familiar with some of these meanings as we move along. All right, so for the relationship of numbers, we use N for natural, W for whole number, Z for integers, Q for rational, R for real, and C for complex. All right, and the subset symbol is showing you how these numbers are related. But I'm going to talk about them in a little bit more detail for you, all right? All right, so starting off with the counting numbers. So counting numbers are numbers that we count with. So naturally, we start counting with 1, right? We never generally start counting with 0. We just naturally say 1, 2, 3, 4, 5, 6. So naturally, counting numbers, we call them natural numbers because that's a natural way how we count. All right, so those are examples. Whole numbers now. Now, whole numbers include natural numbers and 0. So my question is 0 a natural number? Anybody?
No, sir.
No, sir.
No, because we don't naturally use 0 when we're counting. So 0 is not a natural number. So the next question I'm going to ask, is 1 a whole number?
Yes, sir.
Is 6 a whole number?
Yes, sir.
Is 0 a whole number?
No, sir.
I say whole numbers include what? Natural numbers and 0.
Oh, so yes, it would be a whole number, sir.
Right, so 0 is a whole number. So what do you recognize here? Now that I tell you that 0 is a whole number, and I also ask you about 1, 2, 3, 4, 5, 6, if those are whole numbers. Are those whole numbers?
Yes, sir.
Right. So how is counting number different from whole numbers?
Because they don't start with 0.
They which one you're referring to? Whole number count?
Because counting numbers or natural number doesn't start at 0.
All right. And whole number?
And whole number include natural numbers and 0.
Okay. Everybody agree with that? Hold up your hand if you agree. All right. Now, another question I'm going to ask you. Do you think we could merge the two sets together? Yes or no? Can we merge the two sets together? Could we merge the counting numbers and the natural numbers together? Could we just group them into one group and put them together?
You're referring to the counting and the whole number, sir?
Yes, the counting and whole number. Could we make one group and put them in? Could we merge them?
I guess so, but they wouldn't. They will no longer be seen as counting numbers. It would be more like whole numbers.
Okay, but we all agree that natural numbers are whole numbers, right?
Yes, sir.
How could we draw a diagram to illustrate whole numbers and counting numbers merging together?
Maybe a number line.
A number line. All right, but wouldn't the number line involve more than just whole number and counting number?
No, sir. If you start from
Sir?
just putting one side.
Okay, all right, who else is saying something apart from Ms. Waysam?
Sir, I do not remember the name of this diagram, but it's you could use the circles and put the counting numbers in one side.
So you're talking
And the
about
whole
the Venn,
numbers
you're talking about
in
the
the
Venn
other side.
diagram, right? You're
Yes,
to the Venn
sir.
diagram. All right.
Yes, sir.
So you're saying then, all right, I won't, let's say we're not going to use the rectangle, but let's say we start off with a circle, right? How could we draw this circle so that we could involve both counting numbers as well as whole numbers to show that they are related? All right, so let me start off with this one being the circle or the set which consists of whole numbers.
Oh, I'm guessing you'd have an overlapping circle, sir, with the zero intersected.
You're guessing, or are you sure that you'll have some? So you're saying you would have something like this?
Yes, that's what I'm saying.
Anybody else agree with this way, Sam?
Yes, sir.
All right, so describe how you
Yes, sir.
actually do this. Or you actually do it. Give me a second, guys. All right, sorry about that, guys. So according to what we are saying, we would draw a circle. Let me use another. So we would draw the circle here. And so how would we show the other numbers?
So inside the circle that is labeled whole number, we would write down the whole numbers inside there.
Inside here?
Yes, sir.
What numbers you would put in here?
Like the counting number. Hold on, whole numbers like here, like the zero would have already been included. So 1, 2, 3, 4, and it goes on.
All right, my question to you, what would this circle out here represent? What would this circle?
Me make a mistake, you know. This circle would represent natural
Counting
natural what is it? Natural numbers.
Well, you said
And
this
that-
one represent natural,
Yes, sir. But then
but
sir, I think the 1, 2, 3, 4, 5 would have gone at the little intersection.
in the middle, right?
Yeah, and then the 0 would have gone over to where it was.
numbers would go in the middle.
all right. Now, what they're saying is that here, where you have the 0 in the intersection here, you're actually saying that 0 is a natural number as well. But remember, 0 is not a natural number.
Right, sir. That's why I'm saying we
So
should
this-
move the 0 now
All right,
and
so
put it in the big circle.
let us so move the 0 and put it in where? The big, over here?
Yes, sir.
And what gonna happen here now?
In the intersection, we should have the counting numbers.
Intersection, we should have the counting numbers.
Yes, sir. 1, 2, 3, 4, 5, 6, and it goes on.
All right. I think you guys are thinking a little bit too much. How about if we look up here, what you notice about natural number? Are all natural numbers counting numbers? I mean, are all natural numbers whole numbers?
Yes, sir.
All right, so if all natural numbers are whole numbers, what do you think we should put the natural numbers? Be in the whole number circle, right? You agree?
Yes, sir.
All right. So what I would do is to draw a circle within the whole number and put all the natural numbers in that. How that sound to you?
Yes, sir. That too works.
That works. All right, so here we would have the natural numbers here. So we'd have 1, 2, 3. All right, pardon me on this thing. 3, 4. And I'm just going to put some dot to mean that it goes on. All right, now inside this circle, we have the set of natural numbers, but where would we put 0?
Inside the circle of the whole number, sir.
All right, so we wouldn't put 0 in the whole number because it does not belong to a whole number. But
Yes, it does belong to whole
right,
number.
not
but
whole
natural.
number. It does not belong to natural number, so we wouldn't put it in the natural number. All right, everybody following so far? So what you see here from this picture, clearly you see that all natural numbers are whole numbers, but not all whole numbers are natural numbers. Is that clear? All natural numbers are whole numbers, but not all whole numbers are natural. What do I mean by that? These are the natural, all of them are whole numbers. But this 0 is a whole number, but it is not a natural number. So we can say whole number consists of all natural numbers plus 0, right? So all natural numbers by themselves are whole numbers. 0 by itself is a whole number. But we don't include 0 in the natural number because it is not a number that we count with. Is that clear so far, guys? Do we see that relationship with the whole number and the natural number? Raise your hand. Everybody, are you hearing me? All right, so you should be all clear on this. So all natural numbers are whole numbers. All right, so I'm going to look at the other set now. The other set, we know that 0 is not a natural number, but the other set that we're going to be looking at which other set we're going to look at? The integers. All right, integers are whole numbers, include positive and negative numbers. All right, now we say integers are whole numbers, including negative and positive numbers. All right, I think this is a little bit unclear, but what it should be. Integers are whole numbers, include negative numbers. I think the unpositive number is a little redundant because positive numbers are whole numbers. Positive numbers are the counting numbers, you know. They all agree with me? Ms. Trivia? Trivia, are you saying something? I see a hand up. Okay.
No, sir.
All right, so we're saying that whole numbers are counting numbers. Do you all agree? And whole numbers include 0. So 0, 1, 2, 3, all of those are whole numbers. So integers are whole numbers, include, I won't say positive, I won't include the positive. So I'm going to just mark this part out. I will fix this. So integers are whole numbers, include negative numbers, right? So in other words, what you're saying, whole numbers plus negative numbers give you integers. And so when we say integers are positive and negative numbers, we remember that the whole number part is the positive part of the integers. Is that clear to everyone? You understand what I'm saying? Miss Scott, are you understanding?
Yes, sir.
Okay. Miss Green, ask a question.
Can you go one more time?
All right. So just as how we had looked at in the previous one, and we say that, go back up here. We say that counting numbers are whole numbers, including zeros. Sorry, counting numbers include natural numbers and zeros. So what I should have here is that integers include whole numbers and negative numbers. So that's what I should have had here. Maybe I should just fix that now. All right, make it stay until I'll fix it for the next class. So what integers would be, they would give it a set of what? Whole numbers plus a set of negative numbers. All right, so let us think about a Venn diagram, or we could represent these numbers on a Venn diagram.
Including integers overall, sir.
All right, so I'm going to draw a circle again. So let's say that this would be what? Which set would that be? I'm going to draw another set, different color this time. All right, so the relationship here is similar to what we had before. So this one here is a natural number. Let me use it appropriate. This one here is the integer, and I'm going to use Z for integer. So Z is integer. W is what? Whole number. And N is natural number. So we know that the natural number would be 1, 2, 3, and so on. But inside the whole number, we have all natural number as well as zeros, 0. What about the integer though? For integer, all the whole numbers are integers. But in addition to the whole numbers, we also have negative numbers. So we would have -1, -2, -3, etc. On and on. So these are all integers, but they are negative integers. So integers would be what? Positive and negative numbers. Is that clear to everybody? Anybody?
Yes, sir.
All right. So we have the set of natural number within the whole, but we have all the whole within the integers. So what that tells you about natural? Natural numbers are integers and they are whole numbers as well. Is that clear? All right. I'm not hearing anybody. I'm taking that.
Yes, sir.
All right. So who can guess what the next set would be? If I'm to draw another circle around this, what we're going to have next? Anybody can guess?
The rational numbers.
We're going to have rational numbers. Now, the rational number would be which set of numbers? Nobody gave me an answer to what rational numbers are.
Numbers that are written as fractions, sir.
They are fractional numbers. And anybody know what symbol we use for rational numbers? We use the symbol Q. So Q means rational. All right, everybody clear so far? Now, fractional numbers are what we call rational numbers. So any number that can be expressed with a numerator and a denominator, those are called what? Rational numbers. Now, the word rational is coming from the word ratio. Everybody know what a ratio is? Raise your hand. Okay. All right. Is there anybody who don't know what a ratio is? Raise your hand if you don't know what a ratio is. All right. Ms. Travia, what a ratio is? Are you hearing me, Ms. Travia? Ms. Travia? Are you there? Can you respond? If you're hearing me. Or Jano, you hearing me? Raise your hand if you're hearing me, anybody. All right, Miss Green is hearing me. Anybody else is hearing me? All right, Miss Trivia, are you hearing me? Miss Trivia, raise your hand if you're hearing me. Not getting a response from Miss Trivia. Miss Waysome, are you hearing me?
Yes, sir.
Okay. I'm not sure what is happening with Miss Trivia. What about you, Mr. Ajino? You hearing me? It's coming. You hearing me? All right, I'm not sure.
Yes, you know.
You're hearing me now, Miss? Okay.
Yes,
I'm
sir.
hearing you, sir. I'm hearing you.
Okay, good. All right, so I was saying that rational numbers are numbers that have a numerator and a denominator. They can express in terms of a fraction. But where I was saying that the word rational coming from ratio. And I was asking Miss Trivia to explain to me what a ratio is. Can you do that, Miss?
I think a ratio is like how many times a number can go into another number, something like that.
Anybody else want to give me their view of what a ratio is? Miss Cumming?
Sir, I'm not so sure.
Not sure. Miss Scott? Miss Scott, are you there?
Yes, sir.
You know what a ratio is?
No, sir.
Okay. All right. Miss Green, do you know what a ratio is?
A little, sir, well, not so certain. Is
All right. Tell
it
me what you
mean
know. Mhm.
to the power of? As-
All right. So let me give you an idea what a ratio is. A ratio has to do with sharing a whole into either 2 parts, 3 parts, or 4 parts, etc. So if you have, like, say, 12 mangoes and you want to share it between you and your friend. Now, you can choose to share the mangoes in whatever way you want. How would you share the mangoes with your friend, Miss Green? How many would you take for yourself? How many would you give your friend? Are you there, Miss Green?
Yes, sir.
So I was saying, if you have 12 mangoes and you're going to share it with your friend, one friend, give me an example of how you would share it with your friend. How many mangoes you would take for yourself? How many you would give your friend?
I'd share it equally, sir. 6 each.
All right. Is there anybody who would not share it equally? Let me see anybody who decide that they would take more than their friend. Miss Waysome, you'd give your friend equal amount as you?
No, sir.
All right. How would you share it, Miss Waysome? Tell me.
My friend too.
Especially if a Julie Mango, that's true.
Oh,
Right.
East Indian, sir.
East Indian. Yeah. Do you get East Indian where you're at?
No, sir. I have to buy it or
Oh, yeah,
get it from Kingston. Yeah.
Okay. They don't go there.
No, it's on common mango. Even if you try to go them, then turn to common mango after a while.
Oh, okay.
Stringy.
All right. So Miss Waysome said that she would share. She would give her friend 2. So how much would you get out of the 12?
10, sir.
All right. So you would take 10 and you give your friend 2. Miss Green said she would share it 6 for herself and 6 for her friend. So nice and generous. All right. Now, so this is a share. And the share can be represented what we call a ratio. Now, a ratio is how much parts you share it in different parts, and you want to say in terms of the different portion, you see that 10 to 2, this person would get 10 parts, this person would get 2 parts. Now, just like a fraction, you could simplify a ratio by by what you call it, writing it in its lowest term. So if you're going to write this 10 to 2 in its lowest term, you could cancel down by using 2. So you would say 2 into itself goes 1, and 2 into 10 goes 5. Now, the simplest form of the ratio, 10 to 2, would be 5 to 1. It's the same ratio. All it means is that you're keeping it in the same proportion. Even though the numbers are different, if you should increase the numbers, so if you increase the smaller portion, if you double it, then you have to double the bigger portion too as well. If you triple this smaller portion, you have to triple the bigger portion. So if you triple this to 3, then the 5 should become what?
15, sir.
15, good. All right, so that's an example of a share, and it's a ratio. Now the colon would be used to represent the word 2. So when we have 5:1, we're saying that the share is 5 to 1. One person get 5 and one person get 1. Down here we have 6 mangoes to 6. Then we would call this a 50-50 share because you're sharing it equal. And 50-50 meaning that